We will now learn about cloud storage and data migration. We will also review storage scenarios that list common cloud data storage requirements and the recommended AWS services. Cloud storage is a critical component of cloud computing because it holds the information used by applications. Big data analytics, data warehouses, Internet of Things, databases, and backup and archive applications all rely on some form of data storage architecture. AWS offers a complete range of cloud storage services to support all these scenarios. Here, we identify the main AWS cloud storage services. These services are grouped into 4 categories, which are block storage, object storage, file storage, and a storage gateway service. The block storage service is Amazon Elastic Block Store, or Amazon EBS. EBS provides highly available and low latency block storage capabilities for workloads that require persistent storage that can be accessed from an Amazon Elastic Compute Cloud or Amazon EC2 instance. The object storage category includes 2 services. First, there's Amazon Simple Storage Service, or Amazon S3. S3 is designed to store objects of any type in a secure, durable, and scalable way that users can access over the internet. The second object storage service is Amazon S3 Glacier, which provides a low-cost and highly durable object storage service for the long-term backup and archive of any data type. The file storage category has 2 services. The first file storage service is Amazon Elastic File System, or commonly called Amazon EFS. EFS provides a simple, scalable Elastic file system for Linux-based workloads. The second file storage service is Amazon FSx for Windows File Server. It provides a fully managed native Microsoft Windows file system to support Windows applications that run on AWS. Finally, the AWS Storage Gateway Service provides a link that connects your on-premises environment to AWS Cloud Storage Services in a highly optimized, resilient, and efficient manner. AWS also offers cloud data migration services to help move on-premises data to the AWS cloud. With AWS Transfer for SFTP, you can transfer files directly into and out of Amazon S3 by using the Secure File Transfer Protocol. AWS Data Sync automates moving data between on-premises storage and S3 or EFS. Finally, AWS Snowball is a large-scale data transport solution that uses secure physical devices to transfer large amounts of data into and out of the AWS cloud. You will be learning about these services in more detail in this module. This table lists common cloud data storage requirements and identifies the recommended AWS service to satisfy them. You can use the table as a guide to determine what solution to use for a given scenario. Here are some additional data storage scenarios with the services you should consider. We will review these services throughout this module. Let's look at Amazon EBS. Amazon EBS provides block-level storage volumes you can use with EC2 instances. EBS volumes are highly available, and they are reliable storage volumes that you can attach to networks that run in the same availability zone. EBS volumes are storage volumes that persist independently from the life of the EC2 instance to which they are attached. Amazon EBS provides volume types that differ in performance, characteristics, and price. You can select the storage performance and cost that best fits your needs. Volume types are identified by a 3-character name, like IO1 and ST1. They fall into 2 categories. The first category includes solid-state drives, or SSDs, which are ideal for IOPS-intensive workloads. The second category includes hard disk drives, or HDDs, which suit megabytes per second or throughput-intensive workloads. Here's a list of the volume types and their details. Provisioned IOPS SSD, which is also known as IO1, is the first type of storage. It provides solid-state drives, and it is the highest performance EBS storage option. This is the best option for critical, I/O-intensive database and application workloads. It also works well for throughput-intensive database and data warehouse workloads that require low latency. General purpose SSD, which is also known as GP2, is the default EBS volume type for EC2 instances. These volumes are backed by solid-state drives. They are suitable for a broad range of transactional workloads, including development and test environments, low latency, interactive applications, and boot volumes. Throughput optimized HDD, which is also ST1, is a type of storage that is backed by hard disk drives. It works well for frequently accessed throughput-intensive workloads with large data sets and large I/O sizes. Finally, cold HDD, which is also known as SC1, is storage that is backed by hard disk drives. It provides the lowest cost per gigabyte of all EBS volume types. It works well for less frequently accessed workloads with large, cold data sets. For more information about EBS volume types, search in the AWS online documentation. You can use the AWS Management Console or AWS Command Line interface to create a volume. When you create an EBS volume, you must specify the availability zone where it resides. If you plan to attach the volume to an existing EC2 instance, you must create the volume in the same availability zone as the EC2 instance. Here is an example of an AWS CLI create volume command. It creates a general purpose SSD, GP2, volume of 80 gigabytes in the US East 1A availability zone. This AWS CLI command requests the description of the volume that was created. If the command completes successfully, it returns metadata about the volume. This metadata includes information such as the availability zone, volume type, and when the volume was created. After you create a volume, you can attach it to an instance that is in the same availability zone. This command attaches a specific volume to an instance by using the mount point /dev/SDF. It's important to note that you will need the EBS volume ID and EC2 instance ID to attach the volume. For more important information about mount points available in each operating system, search for EBS using volumes in the AWS documentation. You can optimize certain EC2 instance types so that I/O access to an EBS volume is increased. These instances are called Amazon EBS optimized instances. An EBS optimized instance has a dedicated network connection between itself and EBS volumes. This optimization provides the best performance for accessing EBS volumes. It does so by minimizing contention between Amazon EBS I/O traffic and other network traffic from the instance. Specifically, it provides dedicated bandwidth to EBS. You have bandwidth options between 425 and 14,000 megabits per second, depending on the instance type you use. This dedicated bandwidth guarantees performance consistency. As an example, consider a GP2 volume that is attached to an EBS optimized instance. It can deliver within 10% of its baseline and burst performance for 99% of the time in a given year. If an EC2 instance type supports EBS optimization, it is automatically enabled if the instance type is categorized as EBS optimized. Otherwise, you must manually enable the optimization when you launch the instance by setting its Amazon EBS optimized attribute. Also, if an EBS optimized instance type is built on the AWS Nitro system, it can benefit from additional performance increases. After you create a volume, you can attach it to an instance that is in the same availability zone. This command attaches a specific volume to an instance by using the mount point /dev/SDF. It's important to note this system is a collection of AWS-built hardware and software components. These components enable high performance, high availability, high security, and bare metal capabilities to eliminate virtualization overhead. For more information about EBS optimized instances, search for it in the AWS online documentation. Thanks for watching. We'll see you in the next video. We will now learn how to manage your EBS storage with snapshots and instant stores. You can back up the data in an EBS volume to a snapshot. It is crucial to take regular snapshots of any data you might have in development, test, or production. You can use Amazon EBS to take snapshots of your volumes so that you can restore these volumes if the underlying hardware that supports your volume fails or if your volume is accidentally deleted. Snapshots copy block-level data to Amazon S3 infrastructure. Objects are redundantly stored and can sustain concurrent loss of data in two facilities. The first snapshot is a full snapshot of the state of the disk at the time the snapshot was taken. All subsequent snapshots capture only the deltas compared to the previous snapshot. If you add data to your EBS volume after you copy your first snapshot and then create a second snapshot, the new blocks will be copied to S3. The second snapshot will consist of a recipe or a description of how to restore the volume. The recipe consists of the blocks from the first snapshot and all new blocks. Snapshots are incremental, which means that they are only based on deltas. Only the changes from previous snapshots must be copied to S3. If you update blocks on your EBS volume and then create a third snapshot, only the blocks that have changed are copied to S3. The new recipe for restoring the volume consists of the updated blocks and any remaining blocks that are still present on your EBS volumes. You can use the Create Snapshot AWS CLI command to create a snapshot of an EBS volume. Snapshots occur asynchronously. The point-in-time snapshot is created immediately, but the status of the snapshot is pending until the snapshot is complete. The snapshot is complete when all modified blocks are transferred to Amazon S3. You can take a snapshot of an attached volume in use. However, snapshots only capture data that was written to your EBS volume at the time when the snapshot command is issued. While it is completing, the snapshot is not affected by ongoing reads and writes to the volume. This might result in a snapshot that excludes data that was cached by applications or the operating system. To avoid this situation, pause all file writes to the volume or stop the instance before you take the snapshot. If you can't pause all file writes, unmount the volume from within the instance. In particular, if you create a snapshot for an EBS volume that serves as a root device, you should stop the instance before you take the snapshot. The command here creates a snapshot of the volume that is identified by this volume ID and adds a description to it. If the command completes successfully, it returns metadata about the snapshot. The metadata includes information such as the snapshot ID and the start time. Snapshots are scoped at the region level. They are visible only in the region where they are created. If you want to use a snapshot in a different region or copy it in the same region, you can use the Copy Snapshot AWS CLI command. Amazon S3 server-side encryption is based on 256-bit Advanced Encryption Standard, or AES. S3 server-side encryption protects a snapshot's data in transit during a copy operation. The snapshot copy receives an ID that is different than the ID of the original snapshot. The command to copy a snapshot from the US West 2 region to the US West 1 region is shown here. Though snapshots are stored in Amazon S3, they are not directly accessible with the S3 utilities. Instead, you must use the Amazon EBS tools to restore and manage snapshots. To restore a snapshot, use the Create Volume AWS CLI command. Storage blocks on volumes that were restored from snapshots must be initialized before you can access the block. Initialization involves pulling the block down from S3 and writing it to the volume. This preliminary action takes time and can cause a significant increase in the latency of an I/O operation the first time each block is accessed. This is why we recommend the practice of pre-warming the volume to eliminate this penalty, particularly for production workloads. This can be achieved by reading all blocks that have data before you use the volume. The command here restores a snapshot to a new volume of the type GP2 in the US East 1A availability zone. After you restore the snapshot, you can use the describe volume status AWS CLI command to check the status of the volume you restored. You can use Amazon Data Lifecycle Manager to automate the creation, retention, and deletion of snapshots that back up your EBS volumes. By automating snapshot management, you can protect valuable data by enforcing a regular backup schedule. This can help you make sure you have the backups required by auditors or for internal compliance. Finally, automating backups can reduce storage costs by deleting outdated backups. To use Amazon Data Lifecycle Manager, tag your EBS volume. Then create a lifecycle policy that defines the backup and retention behavior you want to apply. A lifecycle policy consists of 3 core settings. First, specify the resource type managed by the policy. In the example here, the resource type is an EBS volume. Next, the policy specifies a tag that is associated with the EBS volume to be managed. Finally, specify a schedule that defines how often to create snapshots and the maximum number of snapshots to keep. Snapshot creation starts within an hour of the specified start time. If creating a new snapshot exceeds the maximum number of snapshots to keep for the volume, the oldest snapshot is deleted. You can use the AWS CLI or the AWS Management Console to create a lifecycle policy. For more information about Amazon Data Lifecycle Manager, search for Snapshot Lifecycle in the AWS documentation. This command shows how to create the IAM role that Amazon Data Lifecycle Manager requires. The output provides the IAM role Amazon Resource Name, or ARN, that Amazon Data Lifecycle Manager needs to generate policies. To use Amazon Data Lifecycle Manager, you must create a JSON policy document. Here you can see the command for the creation of a policy that manages EBS volumes. If the command completes successfully, it returns the policy ID. Note the execution role ARN value reflects the IAM role created in the previous command example. You can use the Git Lifecycle Policy command to view the lifecycle policy. An instance store provides temporary block-level storage for your instance. This storage is located on disks that are physically attached to the host computer. An instance store works well to temporarily store information that changes frequently, such as buffers, caches, scratch data, and other temporary content. An instance store consists of 1 or more instance store volumes exposed as block devices. The size of an instance store and the number of available devices varies by instance type. An instance store is dedicated to a particular instance, but the disk subsystem is shared among instances on a host computer. Be aware that instances backed by an instance store cannot be stopped. They can only be terminated. For more information, search for instance storage in the AWS documentation. Some instance types do not support store volumes. When this occurs, the number and size of available instance store volumes for an instance varies by instance type. If you need high random I/O performance, use instance types that use non-volatile memory express or SSDs based on SATA. These instance types are a good option when you need storage with very low latency, but you don't need the data to persist when the instance terminates. You must specify the instance store volumes that you want to use when you launch an instance, except for NVMe instance store volumes, which are available by default. You can't make an instance store volume available after you launch the instance. After you launch the instance, volumes are available. However, you can't access the volumes until they are mounted. For Microsoft Windows instances, the EC2 launch service mounts the instance store volumes. For Linux instances, the instance type determines which instance store volumes are mounted for you and which require you to mount the volumes yourself. For more information about adding an instance store volume to an EC2 instance, search for Adding Storage Instance in the AWS documentation. Thanks for watching. We'll see you in the next video. We will now learn about Amazon Elastic File System, or Amazon EFS. Amazon EFS is a fully managed service that provides file system storage for Linux-based workloads. You can access files through a file system interface by using standard operating system file I/O APIs. EFS supports full file system access semantics, such as strong consistency and file locking. EFS uses the Network File System, or NFS, version 4 protocol, and it can be used with any Amazon EC2 Amazon Machine Image, or AMIs, that support this protocol. Multiple EC2 instances can access an EFS file system at the same time. This feature enables EFS to provide a common data source for workloads and applications. In addition, EFS file systems can automatically scale from gigabytes to petabytes of data without needing to provision storage. You can mount your EFS file systems on your on-premises data center servers when they are connected to your virtual private cloud with AWS Direct Connect. This is useful if you want to migrate datasets to EFS or back up your on-premises data to EFS. This diagram summarizes the steps for setting up an Amazon EFS file system and making it accessible to an EC2 instance. The numbers indicate the 4 required steps. First, you create the EFS file system. Note that it is scoped at the region level. Next, you create a mount target in the instance's VPC. A mount target provides an IP address for an NFS v4 endpoint, where you can mount an EFS file system. Then you mount the file system on the mount target. And finally, you connect the EC2 instance to the mount target. After you mount the file system on an EC2 instance, you can read and write data to and from your file system. You can mount an EFS file system in your VPC through the NFS version 4 protocol. You can access your EFS file system concurrently from EC2 instances in your VPC. Applications that scale beyond a single connection can access a file system. EC2 instances that run in multiple availability zones in the same AWS region can access the file system. This means many users can access and share a common data source. EFS can span multiple availability zones. If your EFS implementation spans multiple availability zones, you must have a mount target in each availability zone. Here are the main use cases for Amazon EFS. You use EFS as a home directory. It can provide storage for organizations with many users that must access and share common data sets. EFS provides the scalability, elasticity, availability, and durability to be the file store for enterprise applications and for applications delivered as a service. You can also use EFS for your development environments. The Common Storage Repository enables you to share code and other files in a secure and organized way. EFS can be mounted with an NFS version 4 from database servers. This provides a good way to create portable database backups by using native application tools or enterprise backup applications. EFS provides a durable, high-throughput file system for content management systems that store and serve information for a range of applications like websites, online publications, and archives. You can also use EFS for media workflows like video editing, studio production, broadcast processing, sound design, and rendering. EFS provides the scale and performance needed for big data and analytics applications. You can specify 3 main areas so that your Amazon EFS implementation meets your needs. First, you can specify the performance mode. We recommend general purpose performance mode for the majority of your EFS file systems. General purpose works well for latency-sensitive use cases like web serving environments, content management systems, home directories, and general file serving. If you don't choose a performance mode when you create your file system, EFS selects the general purpose mode for you by default. You can also choose the Max I/O performance mode. This mode can scale to higher levels of aggregate throughput and operations per second. However, the trade-off is slightly higher latencies for file operations. highly parallelized applications and workloads, such as big data analysis and media processing, can benefit from this mode. Note, you can't change the performance mode of a file system after it has been created. The second area you can specify for your EFS implementation is the storage class. The first storage class is standard. This is designed for active file system workloads and works well for storing frequently accessed files. You can also choose infrequent access storage. This is a lower cost storage class that's cost optimized for storing long-lived, infrequently accessed files. Finally, the area you can specify is the throughput mode. You can choose between the two throughput modes for your file system. Bursting throughput mode scales and is the default. With provision throughput, you can instantly provision the throughput of your file system in megabytes per second, independent of the amount of stored data. This mode enables you to grow beyond the limits of the bursting throughput mode. Thanks for watching. We'll see you in the next video. It's now time to review the module and wrap up with a discussion of a practice certification exam question. In summary, you learned about AWS data storage options and their purpose and benefits. You now know how to create and manage Amazon EBS snapshots. You also know how to store, retrieve, and archive Amazon S3 objects. Finally, you learned about the main AWS data migration services. Great work! Now, we will review a sample question. Take a minute to review a sample question that could be on an exam. Review the sample scenario and look for any keywords that will help you identify the correct answer. Here, the keywords in this scenario are highlighted. You can now consider the answers. Keeping the keywords in mind, review the answer options. Try to rule them out based on the highlighted keywords. The best solutions in this case are Amazon S3 Glacier and Amazon Redshift Cluster. Now it's time for you to complete the Module 8 guided lab, Managing Storage in AWS. You will also complete the Module 8 Challenge Lab, Working with Amazon S3. Thanks for watching. We'll see you in the next video.
Hello, and welcome to this module. You will now learn about monitoring and security on Amazon Web Services. In this module, we discuss the services to monitor, audit, and maintain your AWS implementation. This module provides a technical discussion of key features of Amazon CloudWatch, including CloudWatch monitoring, CloudWatch logs, and CloudWatch events. You will also learn about AWS CloudTrail for generating audit trail logs and AWS Config for version control and change management of your AWS infrastructure. By the end of this module, you should be able to explain the benefits features of CloudWatch, CloudTrail, and AWS Config as the fundamental services for monitoring and management of your infrastructure. You will also be able to use them and analyze the results. We're ready to go. Let's get started.